The next thing I'd like to bring your attention to is the finger filter and flow control mechanism. So as you can see here, we have the discharge outlet where the rain will enter through the funnel, down through the outlet and into the tipping bucket itself. The finger filter design is such that it resists blocking, and this is one of the favorite features of our customers. This is one of the major issues with tipping buckets in the field, remote locations. If they become blocked, you lose your rainfall data and it's unacceptable. So what we have here is a vertical finger filter assembly. This is about 2.5 inches tall to 3 inches tall. And what happens if there is airborne debris that's blown into the gauge or bird droppings, what will happen, it will actually sit at the bottom, form a false bottom, but it will not impede the entry of rainfall. This is a really, really important feature. The finger filter is very easily removed for servicing, and you'll also see when I take this out is what is attached to it is the actual flow control device. This is what the assembly looks like. Here we just have a stainless steel mesh finger filter, which allows small particles through, so dust, etc. We have some of these gauges in desert areas, pardon me, and that is attached to the flow control mechanism, and this is what this looks like. This flow control mechanism has a reservoir, which is just a hollowed out area inside this Delrin body. Water fills this unit and then it is automatically drawn down by gravity through the outlet. This happens at a consistent rate. So the water always exits from this flow control mechanism at the same rate. So this is really the critical point. I won't take this apart and go through the whole thing, but it's just simply a mechanism that will fill and then automatically drain. There's no moving parts. What this means is that if we can control the flow rate from this device, is that then we can correct the intensity errors that all tipping bucket rain gauges suffer from at higher intensities. WMO has stated this in many reports, as have others, that standard tipping bucket rain gauges notoriously underreport. The reason for that is simply that as a bucket is filling from the nozzle down into the bucket and the bucket is moving through an arc, additional water is still coming in here until the bucket passes the central point. So rather than go into an exceptional amount of detail, all this basically means that low rates, it's not that critical, but at higher rates, and particularly now where we have so many cloud bursts and high intensity storm events around the world, as that intensity goes up, without a correction, the rainfall data will be significantly impacted by the underreporting of the gauge. So this correction mechanism that we've had for a very long time means that the TB3 and TB4, which both are fitted with this, will hold their accuracy of plus or minus 2% from 0 to 250 millimeters an hour and 3% from 250 to 500. So that's around 20 inches an hour. So that's an extremely high accuracy for these intense rainfall events. Matter of fact, the TB4 holds the US record for the largest amount of rainfall measured and collected in the United States since records began. It's a nice achievement for our gauge. TB4, I won't go into too much. The TB4 has exactly the same outer enclosure, finger filter, siphon assembly as the TB4, only difference being the construction of the base material.